Okay, in this video, we're going to take a look at solving an inequality, specifically with fractions in it. And the way that you want to go about starting these problems is to look for the least common denominator, which will be multiplied by each term in the inequality in order to clear out all the fractions and allow yourself to work with a more simplistic inequality. In the first problem that you see here, the least common denominator would be 6. And if you recall, the least common denominator is just the smallest value that each one of these denominators divides into at least once without any kind of a remainder. So it always has to be at least as big as whatever the largest denominator is. So 6 is the number that works for all three of these denominators and therefore is the LCD. That's because 2 divides into it 3 times. Without remainder, 6 divides into it once, 3 divides into it twice. So that's going to be the LCD that's going to work here. So you're going to take the LCD and you're going to multiply each and every term, whether it's a fraction or not, by the terms one at a time. And in each case, specifically in the cases where the fractions are, you're going to see how it gets rid of those fractions. So you can look at this as just the LCD divided by the denominator, and whatever you get from that quotient, you're going to multiply it by whatever else is in the numerator. So this would be 6 divided by 2 is 3. 3 times x, 3x. So that first fraction simplifies to just 3x. Here it's 6 divided by 6 is 1. 1 times 17 is 17, and then of course with that negative in front of it. Moving to the right-hand side, 6 divided by 3 is 2. 2 times x, 2x. And then 1 times 6, 6. And then from there, you're going to try and get all the x's on one side and all the constants on the opposite side. I'm going to move this positive 2x by subtracting 2x. That'll leave me with 1x minus 17 on the left-hand side of the inequality and a 6 on the right-hand side. I'm then going to move the constants, all the constants to the right-hand side, and that'll leave me with x is less than or equal to, because the 17s are gone, 23. When you are asked to give your solution in different forms, this would be part of what you would use if you were going to give it in set builder notation. This is what set builder notation looks like. You started off with symbolism that means, or is read out loud, x is such that, and then after this symbol that stands for the phrase such that, you state the parameters of the solution, which is this right here. As long as the x value is less than or equal to 23, those are all numbers that are in the solution set. So that is what we call set builder notation. Now you're going to be moving away from that in this class. That is type of notation that you would tend to use in the level below this. And then, we want you to move towards being able to use interval notation rather than set builder notation. Interval notation has a lot to do with the graph, stating the interval correctly. So you might want to graph the solutions first. Okay, this is anything 23 or less than 23. So you can just put a 23 right here. In previous classes, when you first learned to graph this, we put a circle and then we shade it in, meaning that endpoint works. But since we're trying to move ourselves towards using the symbols that have to do with interval notation, what replaces a circle, a shaded in circle, meaning that endpoint works. And if you remember, we shade circles in when the endpoint is associated with a partial equal sign. So instead of a shaded in circle, we will use a bracket. The reason that I'm opening it to the left is because the shading is to the left. And the shading needs to come right out of the inside of that symbol. So what this indicates is that the number 23 itself is actually solution. That's what this bracket means, because if that wasn't a solution, if it wasn't included in the solution set, I would use a parenthesis according to interval notation. And then everything all the way up through negative infinity is actually solution. So this is actually a picture of all the solutions. This is what we call the graph of the solution set. And then when you want to move into pure interval notation, you read the numbers that this graph is talking about from left to right, just as if you were reading a book. So you always want to state the smallest numbers first, which if you read it from left to right, you'll be doing that. Everything from negative infinity all the way up to and including 23. So in interval notation, which is the most compact way to state the solution set, it would be everything from negative infinity up to and including 23. All the numbers in this interval are actually solutions. So this is what we call an interval representation of the solution set, or just interval notation. And that's how you're going to be giving almost all your answers in my math lab. Okay, moving to the next problem, we have another example of dealing with an inequality and trying to find the solutions for an inequality that specifically has fractions in it. Again, you're going to want to start off by finding the LCD. The LCD for this problem would be 10. Okay, again, it's always at least as big as whatever the biggest denominator is, and then you have to make sure that these other denominators divide into this LCD that you're coming up with without creating any kind of remainder. And you can see that's true for all three denominators. 10 goes into it once, 5 divides into this number twice without remainder, 2 divides into this LCD without remainder 5 times. So that's perfect for all three. We're going to use this 10 as a multiplier to clean out all these fractions. Now, because some of your numerators contain more than one term, you're going to want to wrap that numerator in parentheses anytime the numerator has more than one term, because you're going to end up distributing. Okay, so again, let's look at simplifying these fractional situations as just division. It's the number on the top divided by the number on the bottom. The number on the bottom is always the divisor. So 10 divided by 2 is 5, and then it's 5 times whatever else is in the numerator, just as in the previous problem. 10 divided by 2 is 5, and then 5 times the remaining items or expression in the numerator would be that, x minus 4. Okay, then we move on to the next, and you can even, make a little note that that's what you reduced the 10 divided by 2. Here, 10 divided by 5 is 2, and then that 2 gets multiplied by this expression x minus 2. But you can see that what you're doing is getting rid of all your fractional situations. And then 10 divided by 10 is just 1. Okay, so we have a much nicer inequality, and you can continue by removing the parentheses now. So now we're distributing. So it would be 5x as well as 5 times negative 4, which is negative 20, greater than or equal to. Remove these parentheses as well. That'll give you a 2x and also a minus 4. And then drop down that 1. Okay, as far as getting ready to solve for x, we're going to get all of our x's on the same side. But before you begin moving things from side to side, I would at least combine like terms. So this is 2x minus 3, while you have 5x minus 20 on the left-hand side. I'm going to move this 2x over here by subtracting 2x from both sides. That'll leave me with 3x minus 20 is greater than or equal to negative 3. Okay, then I'm going to move the negative 20 to the other side by adding 20. That'll give me 3x greater than or equal to 17 when you combine these two. And then divide off the 3, and you have x is greater than or equal to 17/3. So in set builder notation, it would be x is such that x is all numbers greater than or equal to 17/3. If you want to give a graph of that, that graph will help you get the interval notation right. So if you're going greater than or equal to 17/3, you could put the 0. You could put a mark for 17/3, and you can reduce it into you can change it into a mixed number if you want to, but that's not necessary. Just make sure that this is reduced. As far as whether you're using a bracket or a parenthesis, I'm using a bracket because of the equal sign, meaning that this endpoint that the bracket is positioned on, 17/3, that actual number itself is a solution. If it wasn't, if there was no equal sign here, we'd use a nice soft parenthesis. So then here, we're going to say all numbers greater than 17/3 are actually part of the solution set. To go and give your answer in pure interval notation, it would be 17/3 is where the solutions start, and we actually include that endpoint, and then everything over to positive infinity. So we have a problem where we cleared out all the fractions by multiplying by the LCD, presented the solution in set builder notation, although you're really going to be expected almost 100% of the time to give it in interval notation. And this is the graph. I suggest you do the graph before jumping into the interval notation because it really lends itself right to that type of solution. And that is it.